Noem die tipe wrywing wat van toepassing is en toon met vergelykings aan hoe die wrywingkrag bereken kan word. As jy genoeg inligting het, bereken ook die grootte van die wrywingskrag. Okay, so basically we're going to fuse everything we've done so far together. We're going to draw free body diagrams. It's going to be fun. Okay. Hulle sê vir ons by nommer 1, Nokko stoot 'n swaar krat met 'n massa van 50 kg met 'n krag van 60 Newton oor 'n mat. Die krat beweeg nie. So, they didn't ask us to draw a force diagram, but I'm going to start with drawing a force diagram. I'm not going to do it for all of them, just to get us started. Okay. There's a force of 60 Newton being applied on this crate. Okay. Kom ons teken in wat ons weet. Hy is nie teen 'n hoek nie. It's not at an angle. So it's not going to be we have to break it up into the two components. Okay? Hier is wrywing wel ter sprake. Now if you look at the sketches I've drawn it, in which direction will friction be? Yes. Okay? And then the other two forces that we have is gravitation and we have normal force. Nou kom ons gaan sit dit op 'n vryliggaam diagram. In other words, I have these two forces that are exactly in equilibrium with one another. Hoe weet ek dit? Want onthou op die y-as moet alles uitkanselleer. Why do we know they have to cancel out? Because this crate isn't moving. It's not moving in any direction. Now once again, think about two teams pulling on a tug of war rope, né? As al twee spanne presies ewe sterk is, beteken dit mos niks gaan gebeur. Okay? So stem julle saam in hierdie geval gaan Fn gelyk wees aan Fg. Right? Everyone happy with that? Okay. Maar nou gaan ons vir die eerste keer kyk op die x-as ook. On the x-axis, it's also perfectly balanced. Why? Because he is pushing it with 60 Newton. I'm going to call that F applied. And is this crate actually moving? No. So in other words, in the opposite direction, he's experiencing friction that will be exactly the same. Okay? What type of friction is being experienced? Static friction. How do we know that? Because it is not moving. Okay, so kom ons beantwoord die vrae wat hulle vir ons vra. Hulle vra vir ons moet skryf watter tipe wrywing is hier ter sprake? Stem julle saam met statiese wrywing? Static friction. And then they also say show how you would calculate friction. Now in this case, friction is exactly equal to F applied. Nee? They're balancing out. Hy lê teen die boks met 60 Newton, maar die boks beweeg nie. Okay, so friction can't be more than 60, because if friction was more than 60, it would have been moving in the opposite direction. Hulle moet mekaar presies uitkanselleer. Onthou dat ons gesê die wrywing neem toe en toe en toe en toe. As the applied force increases, so does the frictional force. The static friction. Okay? Goed. En in hierdie geval weet ons dit is 60 Newton.
Ons werk altyd max uit.
Ja, ons gaan nie naby max uitkom. Everyone happy with that? Julle almal seker ook dit gekry het. Okay, on to number 2. Number 2, it's still Nuku, but now they're saying he's pushing a bit harder with a force of 80 Newton, and this time the crate, no, 70, sorry. The crate is at the point where it will start moving. So what is he experiencing now? Is the box moving? No. But he is right at that tipping point. So what type of friction is this? Still static, but it's Fs max. Okay, so the free body diagram will look exactly the same. Fg will be equal to Fn. And the applied force will be equal to the frictional force, but this is going to be Fs max. Dit is nog steeds statiese wrijving wat hy ervaar. Still experiencing static friction. And this time you can say, I'm going to calculate Fs max is equal to the applied force is equal to 80 Newton. Ag man, ek bly met die 80. Sorry julle. 70 Newton. Nee. Goeie vraag. We haven't used the 50 kilogram yet. Good. We're not putting in the directions of the friction, maar stem julle saam dat as die krag na regs was sê nou maar, dan is wrywing na links. Okay, so it's either, if it is moving already, it's either in the opposite direction of motion, maar as dit nog nie beweeg nie, is dit in die teenoorgestelde rigting as wat jy wil hê hy moet beweeg. Okay. Now number 3. It starts moving. So these two are still going to be the same. Nothing changed there. His applied force is now 58 Newton. But now remember it is moving. So friction is not going to balance out the applied force anymore. So as jy hom gaan teken, is jou wrywing nou actually kleiner. Okay. Watter tipe wrywing ervaar ons hier? Kineties. Because remember, it's not like a perfectly balanced tug of war anymore. His applied force has actually overcome the frictional force. So the one team is stronger than the other team. For now, I'm going to answer yes, but it's not completely true. Okay. Later, when we get to Newton's laws, there's a bit more to it. Like it's about how it moves as well. But for now, let's keep it a simple yes. Okay. Good. So it's kinetic friction. Now remember, now we can't simply say the two are in equal balance, so kinetic friction will be equal to applied force. Okay? So nou moet ons gaan en ons formules begin gebruik. Do I have the coefficient of friction? Nee, ek kan hom nie verder gaan uitwerk nie, maar daar is een ander ding wat ek kan uitwerk. Ek kan normaal krag 'n klein bietjie beter definieer en sê normaal krag in hierdie geval gaan gelyk wees aan sy gewig. Right? Because in this axis they are balancing out perfectly. Bless you. Okay, grade 11s, that will always be true except when the force is at an angle. So as die krag teen 'n hoek is, dan gaan Fn nie gelyk wees aan Fg nie. Or when the box is on a slope, and the object is on a slope. Okay? So when it's flat on the ground, dan is dit maklik. Dan is die normaal krag gelyk aan die gewig. Okay. And the weight I can calculate. Check my rock gou. Ek hoor nog 'n 0. Okay, so what I can put in there is I can say, if I had the coefficient of friction, I could have calculated the magnitude of friction. MK. M is massa. O, hierdie is die koëffisiënt van wrywing. Hy's nie eintlik 'n N nie, hy's soos 'n U wat 'n so ding het. Okay. Okay, now before I carry on with the next bit, I just quickly want to refer you to top of page 30. Where it says that now you'll see above that they have a whole explanation of how they got to that. You don't need to understand the explanation. Jy moet net daai stukkie in die grys verstaan. Okay, so ons kan die statiese wrywingskoëffisiënt kry, statiese wrywingskoëffisiënt. In hierdie geval is theta die hoek van die skynsvlak met die horisontaal wanneer die voorwerp op die punt is om te gly. So we're working with something that is on an incline. And if they're telling you it's at the moment where it's going to start sliding, then you can use this. Okay? Net in daai geval. So wanneer ons by Fs max is, né? Dan kan jy hierdie gebruik en die hoek wat jy hier gaan insit is die hoek wat hy met die horisontaal maak. And I'm going to show you guys now, we're going to do 1 or 2 examples of those as well. Okay, I'm going to skip over number 4, I'm on number 5. Okay, so they're saying there's a crate with a mass of 60 kilogram. En hulle sê vir ons die laaibak word stadig gelig, die vloer van die laaibak maak 'n hoek van 10 grade met die horisontaal. Die krat beweeg nie. So this crate is not moving. Okay, let's start with the force diagram. Do you guys agree that it has weight pulling straight downwards? Nee? Maar onthou, ons gaan mos nie met hom net so werk nie. Hoe gaan ons met hom werk? We are going to go and break it up into its 2 components. Okay, so as ek by die vryliggaam diagram kom, gaan ek net die 2 komponente inteken. So this is called FG perpendicular. No, I'm lying. No, I'm not lying. And this is called FG parallel. Wat is daar nog hierso in werking? 2 more forces. Wrywing, in watter rigting gaan wrywing wees? Op teen die skynsvlak, né? Watter soort wrywing is dit? The crate is not moving. Okay, what else am I missing? Good, the normal force. Okay, ja. Dis waartoe ons gaan. En dis als Isaac Newton se skuld. As jy wil kwaad wees vir iemand, wees kwaad vir hom. Okay, going to draw the free body diagram. Now remember, on the free body diagram, you are either putting in the force or you're putting in the force's components. I'm going to put in the components. Okay, so we have FG perpendicular, and in the opposite direction, we have the normal force. So let's just quickly stand there for a second. Okay, wat het ons gesê? Hulle twee is in equilibrium met mekaar. Stem julle saam, daar's geen ander kragte wat op daai as werk nie. Right? Do you agree? So in other words,